Okay, so on this one, we are not even stretching it, which is the new thing for today. This is just moves and flips. So let's go with Grace. Can you tell me what happens on the inside there? Left 3. A lot of kids would have said right 3, and you're right. It's left 3, okay? Then this one is down 6. That front one, some sad kids are going to say flip, and I might have to take off 5% because they should have said reflect. What kind of reflect, though? Vertical. And the reason you can know for sure is it's high, horizontal on the inside, and vertical on the outside. Whether you're in the front or the back, that's vertical on the outside. All right. But what if there was a stretch? Watch. All that would be different is you'd put like a 2 there. And then all of a sudden you'd have to say, and that is vertical because it's on the outside, stretch. And how would it make the graph different? It would make it more vertically stretched. It would be taller than it used to be, kind of stretched out. Like if it was made of rubber and you grabbed it and you pulled it up like a rubber band, it would just kind of stretch. All right. So, all said and done, if you see one of these in front of a problem, you got to know that it's been stretched or shrunk, and if it's a whole number like this, it's stretched. If it's a fraction, it got shrunk. And all that'll be different on your XY chart is you'll just use the 2 as you're sticking a number in. Like I always say to make this equal to 0, right? So 4 would be the logical thing to stick in. So I stick in the 4, and if it equals 0, it's pretty slick because you just have to go 2 times 0 and you get 0. But if you put in something like 5, I want you to see if you can do it. Everybody put in the 5 and see what you get. You just got to include the 2. Don't forget that it's a 2 times on the outside. Ian, walk me through it. Ian K. I got 5 minus 4? Okay, we're putting in 5 right now. I'll come back to you in a minute. Stella, if I put in 5, I get 5 minus 4. What's that? Okay, 1. And then it's absolute value of 1, which is still, and then times it by 2 makes 2. There you go. Who had 5 comma 2? Good. And so you just get the numbers the same way we always have. You pick a number that makes the inside 0. All right, if I put in a 6, Ian A. Walk me through putting in a 6 right here.
2 times 2, 4.
You got it. Okay, and then that's it. And this was a vertical stretch. So when you actually look at your V shape, it would be moved right 4. So here's my V shape, right 4. And then it's stretched, so it's a little taller than it used to be. It's more like the blue one. That's what makes it vertically stretched. You graph these points, you'd be able to see exactly where it is. Okay, cool. And that's all I had to teach you. This was the stretching and shrinking part. And what if they have a 1/4? You could times by 0.25? If you don't like using a calculator and trying to enter exact fractions, do you have 1/4 memorized? What if you didn't? Well, you could always go 1 divided by 4, but you'll have to put it in parentheses on a calculator. Calculators would be allowed for this, but hopefully you could just go times 0.25. I have it memorized. Maybe you don't. I don't know. But if you don't, you just put it in parentheses in a calculator, and parentheses 1 divided by 4 will come out to 0.25. And then you put it at any numbers you want, like 2, 3, maybe -1, maybe 0. And then just find a bunch of points and graph them. All right, I think we should get to the homework. Everybody find the worksheet that is assigned for today. Yesterday, we had this worksheet that we're going to collect in a bit here, and a lot of people didn't know what to do here, and I had to tell them, and I bet you know now, what kind of numbers can you put in there? What kind of numbers can you put in there? Some people are like, you can't do that because it'll be square root of a negative, and you can't do that. You can put in certain kind of numbers here. What kind can you put in? Negative numbers. So like, for example, you could put in -4. And then you'll have negative of -4, which turns back to +4, and then you can do the square root. So the trick on that one was just use negative numbers. All right. So please find the worksheet that was assigned for today. And Hallie, could you read me number 1?
R of x equals x squared that has been vertically stretched by a factor.
Vertically stretched by a factor of what? Well, then it's just y equals 3x squared. Do they want us to graph it or anything, or they just want you to write it? Just write it. Good, then that's done. Megan, can you read me number 2?
F of x equals absolute value of x that has been vertically reflected.
Absolute value of what?
X that has been vertically reflected and moved leftward.
And left, stay in your seats, we're almost done. Vertically reflected and left what?
4.
Okay. We're not going any faster just because you move your desk. Okay. So this is vertical reflect. Vertical's on the outside. And then left 4. How do I do that? That is left 4 and vertically reflected. There's your answer for that one. Okay, we'll finish this after lunch. Okay, so when we left, we had started the first couple homework problems. And during the second part of class here, I'm going to have you each walk up and show me the homework from yesterday. And if there's anything on there that you don't understand, I'm going to ask you to sit down and we'll talk about it for a minute and see if we can get that fixed. Because those things are super important. They're on their next test. And if you didn't do so well on it, as long as you fixed it, it's all good. All right, let's do one more before we head and be done with the video here. This is number 3. Savannah, could you read me number 3?
T of x equals the square root of x that has been horizontally shrunk by a factor of a half and moved up 9.
Okay, as soon as you said horizontally shrunk, I knew I was going to have to put something right here because that's horizontal spot. Okay, so then what do I put there? Well, horizontally shrunk by a factor of, what did they say? I missed the number. 1/2? Okay. All right, so then if they want to shrink it with a 1/2, then I know this is going to be weird. I'm going to put a 2 there. Because these are not what you would expect. You'd expect me to put a 1/2 right there. And it's the opposite of what you'd think because it goes on the inside. It's the opposite of what you'd think. So we don't use a 2, we use a 1/2. And then up something that I can trust because it's just on the outside and we can trust that. Up seems like plus, and it is. How much up was it? Thank you. So then there's my equation. Square root of x. Oh, I crossed it off by accident there. Let me try that again. There we go. Square root of x. But that's horizontally shrunk. It seems like it got twice as horizontal, twice as wide, but it's the opposite of what you would think. That's actually a shrink by a factor of a 1/2. All right. So there's your equation. And that was number 3. All right. So the rest of the time is you working on that worksheet and me calling kids up one by one to put your grade in the grade book for yesterday's little quiz and talk to you about it a little bit. And that's all I got for you for today.